Today we're going to look at the pre-calculus notes for chapter 3.2, properties of logarithms. If you could write your name and what period you're in, that would be great. So today we're going to be looking at logarithms and we're going to be evaluating them with a calculator. So that's the main reason I have a calculator here. Okay, so anytime you see log base 10, log base 10, log base 10, that's what your calculator automatically comes in. And so you can just hit the log button and then hit equals. So for the first one, we're going to type log of 140. Oh, calculator's not on. Helps turn the calculator on. So we're going to hit log of 140 and then just hit the equal sign. And it's going to give us roughly 2.1461. And you use that little wavy equal sign just to show that you've rounded. Okay? And let's just round to how many places? 4 decimal places, okay? Log of 50, I'm not even going to show you. Let's do log of 1 over 700. So if it's a fraction, just type it in with the division and hit the equal sign, so you should have approximately negative 2.8451. Okay? All right. So sometimes instead of seeing log, you're going to see natural log, the ln. So instead of using the log button, you're going to use the ln button. And the only one that's tricky there is the third one. So let's just do that fraction together. 5 divided by 748. Hit the equal sign, and you're going to get roughly negative 5.00797. Okay? If you have any issues with your calculator, let me know. Handheld's obviously the best, but you can also open up Desmos and use just the scientific calculator that's in there. You can also use the calculator that's in your cell phone. You might just have to type things in a different order. So kind of experiment on the easy ones and make sure you know the correct order. And then whatever order you use on the more complicated ones, you'll already have practice. Okay, so those were all with log base 10. So what if your base is not 10? What if your base is 5 or your base is 7? Okay, then you're going to use something called the change of base formula. And the change of base formula is this guy right here. So if you have a highlighter, you should highlight this guy. So, oh, there we go. I'm just going to highlight that. And if you have a note card, that would be a good one to write on the note card. Basically, if you have log with a base of anything other than 10 of a number, you're going to separate it into log base 10 of the number x, whatever it is, divided by log base 10 of this, whatever the base is, okay? So, for example, log base 5 of 32, you're going to rewrite it as log base 10 of 32 divided by log base 5, or log base 10 of 5, okay? So if you're typing that in your calculator, you're simply going to type the log of 32, and then we're going to divide that by the log of 5. Is that typed in right? Yes. Okay. And then we should get did I type something in wrong? All right, let me pause that. Okay, I typed it in correctly. All right, so log base 10 of 32 divided by log base 10 of 5 is roughly 2.1534. It's kind of hard to be going back and forth. All right, and another example here, log base 7 of 87. We're going to take the 87, put it in the numerator, and then the log base 7 in the denominator, punch it in the calculator, and it's going to spit out that decimal for you. Okay. Here's some more practice of rewriting with the change of base formula. So we're going to go log of 15 divided by log of 6. Okay, and log of 56 divided by log of 4. All right, so just make sure you close those parentheses. So for this one, for the middle one, you want to go log of 56 divided by the log of 4. I think I didn't close a parenthesis. There we go. All right, and this third one is a little tricky, okay, because we want to change base. So we're going to say the log of 43 over 70 divided by the log of base 20. Okay, so let's do log of that fraction 43 divided by 70 divided by the log of 20. And you should get this weird decimal, roughly negative 0.16266. All right, now we're going to solve some of our logarithms, okay? So what you're going to notice with this logarithmic equation here is we have a log base 3 on the left and a log base 3 on the right. So when you have same log on the left and same log on the right, you can take the statements and put them equal to each other. So you can just take the 2x plus 3, put it on the left, the 15, put it on the right, put an equal sign in between them, and then solve them like you're in pre-algebra. Okay, subtract 3 from both sides, which gets you 12. Divide both sides by 2, which gets you 6. Okay, these are both natural logs. So if your natural logs are the same, you can take the 22 and the statement 33x minus 5, put an equal sign in between them, add 5 to both sides, which gets you 27. Divide both sides by 3, which gets you 9. These two are a little more complicated, okay? So the one on the left is being multiplied by 5. So the first step, just divide by 5, which gets you 4 here, okay? Then we don't have a log on this side, but we do have a base of here. So we could rewrite that as an exponential. We're going to take that base of 3 to the power of 4 and set it equal to w minus 6. And then 3 to the 4th power. You can do that on your calculator. You should get 81. And add 6 to both sides. Okay. All right, for this one, we want to start by adding 12 to both sides. So 0 plus 12 is 12. And then we are multiplying by 6. So divide both sides by 6, which gets you 2 over here. And then we don't have logs on both sides, so we're going to write this as our exponential. We're going to have 8 to the 2nd power. So that's right here. And the 4 minus 3x, you can put it on the left or the right side. It doesn't really matter. 8 squared is 64. Subtract 4 from both sides to get 60. And then divide both sides by negative 3. And you end up at negative 20.